In the 14th century, naval architecture was limited by human muscle. Building a ship meant placing a heavy timber in front of a master shipwright and waiting for them to shape it by hand. This slow pace was a requirement of the Mediterranean standard, the Roman hull-first method. Shipbuilders constructed the watertight outer shell of the vessel from custom planks before installing any internal structural ribs. Without an underlying frame to serve as a guide, every wooden plank had to be shaped and beveled by eye to fit against the one beneath it. The entire process relied on the specialized skill of a few master craftsmen. If a plank was cut slightly off, it was discarded. This reliance on custom fitting led to significant lumber waste and stretched the construction of a single vessel across months or even years. For a maritime empire, this created a ceiling on power. Protecting trade routes requires a massive fleet, but an empire cannot project power if replacing lost vessels takes a decade. Maritime dominance was limited by the friction of artisanal, bespoke manufacturing. To scale power, a state had to reorganize the way it built. The Republic of Venice faced this constraint more than any other power. Without agricultural land on their lagoon, their survival relied on seaborne commerce. They connected Europe to the Silk Road, trading with Egypt and Syria. Protecting these lucrative supply lines required a military force capable of controlling the Mediterranean. The state solution was the Artisanal. This complex covered 45 hectares, consuming roughly 15% of the city's total land. The Artisanal operated as a state-owned, centralized factory. Every basin and workshop was designed for the production and maintenance of warships. High walls, 15 meters tall, and a guarded perimeter isolated the site from public view. These defenses protected the Republic's industrial methods from foreign rivals. Within these walls, the state consolidated every stage of maritime production. They began reorganizing ship construction to remove it from the variable skill of individual artisans. In the 1320s, the Republic opened the Arsenale Nuovo. This expansion introduced a change in assembly logic, frame-first ship construction. Instead of building the hull plank by plank, workers first erected a skeletal oak frame. Once the skeleton was set, the exterior planking was simply attached to the outside. This chart displays the efficiencies of the shift. Building the skeleton first lowered raw material consumption and cut total labor hours. Because the frame dictated the shape, workers no longer fit planks by eye. Parallel teams could now hammer boards onto different sections simultaneously. The proti, or master shipwrights, moved away from physical labor. They became quality control overseers, managing large teams of laborers to ensure the frame met the state's specifications. Frame-first architecture transformed shipbuilding from a specialized art into a repeatable geometric process. Because the ships were built to a uniform template, their individual parts became interchangeable. The Arsenal's operation was built on strict component standardization. During peacetime, the state mass-produced thousands of separate subcomponents. Workers shaped identical oars, wove sailcloth to specific dimensions, and stockpiled keel beams in warehouses. The Tana, a workshop built in 1579, demonstrates this scale. This 316-meter-long building was used exclusively for twisting hemp fibers into uniform nautical rope. To ensure uniformity, the Republic implemented a grading system. Every coil of rigging produced here was tested and labeled to guarantee it met identical tensile strength metrics across the fleet. Standardization extended to the armaments. Blacksmiths cast uniform bronze artillery, while workshops produced identical crossbows and bakeries manufactured standardized rations. By storing thousands of identical prefabricated parts, Venice banked naval power. This allowed the state to activate its fleet the moment war declared. Feeding these warehouses required total vertical integration. The Republic controlled every resource, ensuring they never relied on external suppliers for critical materials. The state owned and managed forests in the Montello Hills. These woods were audited and harvested exclusively to supply the Arsenale with beech and pine. Officials even manipulated the growth of the trees. They tied young pine saplings to the ground, forcing them to grow into precise curves that would later be harvested as pre-shaped keel beams. These materials were processed by the Arsenalati. This disciplined workforce lived in state-provided housing and worked under a strict hierarchy of masters and apprentices. Administrators used ledger systems to track the facility's inventory. Every barrel of pitch and every timber moving through the shipyard was recorded to monitor efficiency. The Arsenale functioned as a closed-loop system, controlling a warship's life cycle from the planting of a seed to the casting of its cannons. These prefabricated parts were assembled using a moving waterborne assembly line. The assembly sector was designed for flow. Dry docks fed directly into a central canal lined by covered worksheds built over the water. The shipyard inverted the usual assembly process. Instead of moving materials to a stationary ship, the hull was towed past stationary caches of materials. A hull was towed to the first station, where cranes lowered prefabricated masts and decks into place. At the next shed, workers loaded graded rigging, sailcloth, and standardized oars. In the final bay, the ship received cannons, gunpowder, and precise rations before exiting. Using the water as a conveyor, the Arsenale achieved mass production centuries before the Industrial Revolution. This system allowed the Arsenale to launch one fully armed war galley every single day. During war, the city mobilized 16,000 arsenalati. This workforce allowed the factory to sustain production quotas for as long as the state required. The efficacy of this system was proven in 1570, during the mobilization for the Battle of Lepanto. While other powers struggled to build their fleets, Venice drew from its warehouses. They rapidly supplied over half of the entire Holy League's fleet using their stockpiled parts. Every galley produced this way was a standardized unit of combat, ready for immediate deployment in the lagoon. The Republic of Venice maintained its maritime power through industrial efficiency. Their dominance was the result of the repeatable, calculating output inside these shipyard walls.